going to type in. Okay. So we're going to start in just a few moments. Let everybody get situated. Okay. So this is Intro to R. My name is Ying. This is Priya Oberoi. We're part of the Commerce Data Service here in the Department of Commerce, and we're offering this course for everybody as part of the Commerce Data Academy. So just a little bit about us, our contact information, my amazing mustache. And these are the goals we're hoping that you'll take away with for this class, at the very least, is that a little background on R, some basic syntax to get you started, how to just exercise how to import, view, play with, and visualize some data in R, and really learn in the background of how R operates and thinks to help you as you program. So as we get started, like the big question you want to ask yourself is, what is R? For people who aren't familiar with R, it is a free environment for statistical computing and graphics. That's what it's primarily designed for statistical computing. It is an object-oriented programming language for those who know what that is. And below you'll see just the screenshot of base R. It's on that laptop. Okay, so we're trying to make the slides bigger on the WebEx thing. So if you hold on for just a sec. No. Can you kill the box on the side, the X on the side? Did you? That just may be it. Yeah, okay. Okay, sorry for the short delay. So picking off where we were, so you'll see below just a screenshot of base R, which is just a command line. But what makes R really suited for statistical computing is that it has the ability to import packages into R to extend the functionality of it for all these different methodologies that you may be familiar with, some you may not be. And in total, there's more than 6,000 packages that extend the functionality of R. So that's a huge library of things that you can extend with. And what that really means is that comparing it to traditional statistical packages that you may be used to using, like SAS or SPSS or Stata, that it compares much better. It has much more functionality across the board. So let's just get started with some basic vocabulary that we'll be using through the course, so you'll get up to date with it. Packages, what we mean by packages are just basically a collection of data, functions, and methods that you can add to extend capabilities, like I mentioned before. So the analogy sort of is adding an app to a phone to do more with it. When we talk about scripts, what we're really talking about is the R code you wrote yourself. So the commands that you put together that you want R to execute. So that's your script. A function is basically a command that does something to an object in R. An object, speaking of which, is basically some data structure in R. So it's basically a collection of data in R. That's defined. A data frame is an object with rows and columns in it, so think of like a traditional Excel table. And when we talk about a workspace, it's basically the active working memory in R. So when R is active, it has the memory, it stores objects in the memory. And that's what we call the workspace. So we also asked you to install RStudio if you could. And so what is RStudio? And it really is an extension of R. It's actually, you can kind of think of it as a GUI on top of R. And what that means is it's a free user interface that makes R much easier. As you looked before, we had just the command line for base R, but in R Studio, we have windows for the console, the editor, things about your command history, about the different objects you've defined in memory. You can all see that there. So it makes it much easier to program in R. So we can start with a little history of what R is for people to just get a background. And R is actually an implementation of S language, which is a very early statistical language, basically created during Bell Labs, along with C. So for people who are even familiar with that. Again, it is object-oriented, meaning we're defining objects in memory in R, and we're doing actions on top of it. But what makes R unique is that it inherits a lot of the lexical scoping from Scheme, which is another language. So what I mean by lexical scoping is that variables are defined from your script. So when you define commands and define objects, the order in which you write them is the order in which they get executed. So that's lexical scoping. So just an additional trivia fact, R was created in New Zealand, actually, by Ross Ikeka and Robert Gentleman. And so on to the basics. We talk about packages. What we want to, so the basic commands to install packages and to load them into R are here. So basically, if you have R pulled up right now, you can type in install, or R Studio, you can type in install.packages, open and close parentheses, and you'll see a list of all the packages currently installed in R.
In R Studio, you type it into the console part, the bottom left.
The console. Yep. Yeah, so we'll get to that. So the first part lists all the actual packages you have. We asked you to install a few packages before class, and you'll probably see them in the list of a large list of packages already in R. When you want to install an additional package, you can look it up online. There's a CRAN repository. You would put the second command in, which is install.package, and single or double quotes doesn't matter. It's just the string that is the name of the package. But there's a difference between installing a package and loading it into R, into the working memory, so the workspace of it. And so to do that, we'll load the package in once we've installed it. And to do that, we just call it as a library. So basically, it's library, the package name, without quotations. Okay, so the next basic thing we kind of want to do in R is to know how to comment things out. So what is the comment syntax for R? And that is just the pound sign. So you'll see here, any line that begins with a pound sign is commented. This code does not execute. This line doesn't run through the parser. R skips it. Anything immediately following it is skipped, but anything preceding the pound sign is executed. So you'll see here, the second line, all of it is executed. The third line, only the part before the pound will be executed. Oh, okay. So I'm going to switch off to pre to do the next section.
Okay, so we looked at that commented section. Oh. Okay, so now that we saw what it looks like to just put something, to type in a comment, which means put in some text into that, not into the console, but into the part where you write those scripts that does not execute, we're kind of moving over to writing commands that actually do execute. R tries to interpret what you want. And so the very first thing that kind of everyone needs to know is, like, we talked about objects, like it is a data structure. It's something kind of, it is an object that you can perform functions on top of in R. And when you're defining those, for example, here, you can see that I'm creating an object called class name. And then what I'm assigning to it is a string. And that string is just the text, like intro to R. And you can tell it's a string because it's in quotes, and double or single is fine. And the way that the operator you use to assign is that arrow. You technically can, if you just like look at intro to R tutorials after this, you'll see that you actually can use the equal sign, but that gets really confusing. It's not a great practice, especially because you're going to use that in different ways when you're actually writing R scripts that don't involve assigning anything to an object. So this is generally safer, and you'll see that this is what people use the most. So here, you can see an example of using an equal, like x is equal to, and here we're doing a range 1 to 10. Actually, let me swap over to R, and we can actually do that. Okay. For the slides, we'll be sending those out in about a week or so. We send a link that has the slides and the recording and everything like that. Okay. So you can see here, I said, okay, can you take the sum, and x is equal to a range 1 to 10. And what it did is it gave me a sum of that, 55. But if I look for an object called x now, we didn't actually create an object called x. It says object x not found. Versus sum 55. And you can see here, it's giving me the sum again, but I also assigned 1 to 10 to x. So x is now an object that has those values, 1 through 10. So that's a good example of, like, that would be really confusing. A big part of R is you want to be able to read people's code easily and understand what it's trying to do, especially because you're going to be, a lot of times when people are building R scripts, it's something that you're doing, you want to be able to have output, like actually build something quickly, which means that in a month you're not going to remember what you were trying to do. So it's helpful. So just now when we were going through that example, we saw two types of data. We saw a string, which is just text and it was in quotes, and then we saw numbers, like they range 1 through 10. So those are examples of types of data. So numeric, which we're assigning the object variable 1, the number 1, character or strings, and then logical. And these ones, it seems when you hear about the idea that there is, like, can be true or false assigned to an object or a list of true or false values, it sounds like it's something that could not be very helpful. But R actually relies on this pretty heavily, and we'll see how that works. So then we also have data structures, which, as you might imagine, involve data types, right? And so there are a couple of ways of looking at data structures within R. So you'll see on this little table here, and this is actually like a handy table to reference. So homogeneous just means, for that column that says homogeneous, it just means that within that data structure, you expect all of the same data type, whether it's all numeric, all character, or all Boolean. Or logical, sorry. And then, or you can expect a data structure that uses both types or multiple types, and that's that heterogeneous column. And then for each row, if you think of like the data structure I think most people think of is that row and column, like Excel sheet looking thing. that is an example of a 2D data structure because you have data along columns, data along rows. And you can see here that a matrix and a data frame are examples of that. But you can also have a one-dimensional data structure. So an atomic vector or a list are, like 1 through 10 that we just did that sum of when we created that object X. That is a one-dimensional data structure. And then we have arrays, which mess with that quite a bit. They're actually a little bit rare. You use them sometimes in R, but usually when I see them, it does give me pause because it can have multiple dimensions, ultimately. And we can see what that looks like as we're going forward. So if you know that if you are looking at someone's R script or you're building something and you've just assigned something to X, and you want to see what kind of data structure you're looking at, like is X an object that is rows and columns, or is it just one, like is it just the value, or is it just a string? These functions are really helpful to evaluate that. So whenever you see something like this, where it's type of, and then open parentheses and close parentheses, that means that you can place arguments within those parentheses. So if I were trying to figure out what X is, I would say type of, and then X. Actually, type of X without typos. And it says that's integers. Also, I think, I imagine some people are using text editors, some people are using RStudio. It is really helpful to work in RStudio, if nothing else, just while you're typing. It'll try to kind of complete things for you, like the open and close parentheses. So for our next one, if I want to look at the length of X, as soon as I hit open parentheses, it'll also give me the close and put my kind of blinking cursor in the middle there, which is helpful. But also, if you saw while I was typing, it started to give me a list of functions that I thought I might want. And it tends to put like the most frequent ones at the top. Length of X is 10, which is to be expected. And then dimensions. Dimensions work when you're talking about something that has more than one dimension, right? So the 2D and ND data structures, that's when it'll tell you, okay, this is this many rows by this many columns. And attributes. So that tries to give you some metadata about the object that you're looking at. So for X, so it tends to work on 2D and ND structures, not so much on that. I happen to have, actually, we'll loop back to that, and we'll see, we're going to work with a data set that, one of the data sets that R kind of provides, and we'll use attributes a lot when we're doing that. Okay, so now I'm going to go into each of those bits. So the very first thing, the homogeneous one-dimensional structure, atomic vectors, or the heterogeneous version of that, which is lists. So atomic vectors, they're flat in that, one-dimensional, and they're made up of one data type. So the X that we created with 1 to 10 in it, that's a vector, and because it has all numeric data types in it. But a vector can also be all strings or all true, false. And a list have different data types, and also they don't have to be flat. So, for example, the first one here, this is just a list of 3 numeric elements, a false, and then some string in there as well. But also, a list can be made up of lists, or it can be made up of vectors. So you start to say this is a list of, if you were thinking about an Excel sheet and you had 5 columns, you could think of kind of the header for each of those columns. If you put them together, that is one list, and within it, they each have a list of values, right? So you can kind of start to build data structures that way. So matrix is 2-dimensional, rows and columns. It's used quite a lot. And this is an example of how you might set up a matrix if you weren't just pulling in data, like you were generating data, you were building a matrix. So what you see here is the function, which is matrix. And then you're starting to define arguments in there. So you're saying 1 through 6, like here are the numbers 1, 2, 3, 4, 5, 6. And I want you to take those numbers and build a matrix that has 3 columns and 2 rows. So what R will do is build what we see at the bottom here, which is 3 columns, 2 rows, and it just assigns numbers 1 through 6 along each column. If you did it this way, where we said 1 through 6 like as numbers, yeah, it will.
So the question was, does
sorry.
it know automatically to define the data type as integers?
Yes. If you had instead given it kind of in parentheses, said, here's a 1 in quotes, and then separated with a comma, and here's a 2 in quotes, and then it would have defined them as a string. So data frames also 2D, rows and columns, and they can be made up of a list of vectors. So what you'll see is this looks a little similar to the way we created matrices. Like we're saying, here are the numbers 1 through 3, and they are assigned to X. And here is A, B, and C, and they're assigned to Y. I want you to put that into a data frame, and what it will do is take X and put it in one column, and Y and put it in the second column. So data frames tend to be they tend to take up a little bit more space than matrices, but it also means that you can do things like define what your column names are and kind of like loop through those. So when we're looking at data frames, which we're going to work in primarily, you'll see that you often want to access parts of the data frame, whether it's a particular column or range of columns or range of rows or just one particular element, like a cell. And when you do that, the syntax is that you'll put the name of the object, you see at the bottom here. The name of the object, like here it'll be df, and then in square brackets, the row and the column. And we'll see that there are a few different ways to say what the row and column are. We can actually use the column names, or we can just say, the first row. So subsetting, actually, I think a lot of R is made up of subsetting. But if we were to create a vector, and it's made up of those 4 numbers, we can define kind of subsets to that vector and pull out values that we're interested in. So there are 3 general ways to do that. One is using positive integers. So what you're doing at that point is you're saying, here's if you have like an index, if these 1, 2, 3, 4 elements in this vector, if they have an index of 1, 2, 3, and 4, I'm going to reference them using that index. So that very first one is saying, give me everything in that vector that's 1 to 2, like that has an index of 1 or 2. And so it'll return 2.1 and 4.2. So you're kind of like giving it like a location. When you're using negative integers, you're doing the exact same thing, except for at that point you're telling it what to exclude. So if you say, don't give me 1 and 2, it'll give you everything but those 2. But either way, you're doing something very similar. You're giving it location. And then there's kind of the logical vectors that we talked about earlier. So what you're doing at this point is saying, you have a vector of four things. I have an idea of which of those 4 things I want. I'm going to give you that logical vector, and you're going to superimpose it on top of a vector and return the things that say true, that match up, right? So here, the vector that I passed it, and you'll notice the C right before the parentheses inside the square brackets, that's exactly how we define the A vector values as well. I give it true, false, false, false. It puts that kind of on top of our vector, and then the only thing it should return is 2.1, because that's the only one where the 2 met up and it was true. Okay. So we were looking just now at subsetting for vectors for our one-dimensional data structure. So if we're looking at two-dimensional data structures where we have a data frame that has two columns, X and Y, and then those values in there, at that point, we can, kind of similar to exactly how we were subsetting before using numbers, using the index location, we can do that again, but there's kind of an additional component of this. So if you see here where it says based on row number, we have a data frame, we're defining, we say what object we want, which is the DF, and then, can you see my mouse? Yeah. What I'm saying is in the row and the columns, if, yeah, let me go back to this real quick. This part right here, where I said that there was an object and there is square brackets, and then there's two parts inside of it. There's like row and then a comma and then column. That comma is really important because that tells R which thing you're referring to. Are you talking about things that are in rows or things that are in columns? So if I go back here, you'll notice there's kind of a hanging comma right here. So what I've told R is that I would like you to return things that are in position 1 and 3. And because I put it before this comma, I'm talking about the rows. So this first row and this third row. And then anything that I put after that second comma would define what, again, like what it's, if I have any specifications for what column to return. But because I left it empty, it's going to return everything. So let me do this. Data frame. Sorry? I don't know if I can actually make the text bigger on here. Do you know how to make text bigger?
Yeah, look at the view.
Oh. Cool.
Is that better?
Second? All right. Three, and then my second column is made up of 4 through 6. 4, 6. We now have this data frame. And I say I would like the first and the third row, and can you just return everything that's in that first and the third row? 1 and 3. And it will return the first and the third row. If I excluded that column, or that comma afterwards, it's unsure when I say return 1 and 3 if I mean 1 and 3, the first and the third row, or the first and third column. So that's why it gives me an error. So similarly, we can decide that we want to return things based on the column, and if that's the case, you put it after that comma. But you can also have our return parts of the data frame that are based on what the value of the elements that are in there, or that's in that row or in that column. So when you're doing that, you can see here what I've said is, here's for a data frame for the DF object, I would like you to look at the Y column and return all instances where it equals 4, right? So data frame 4, and it returns because it returns the one row that has 4 included in there. So something I kind of want to point out at this point, because I feel like we talked about the logical vectors, and I think this might help kind of clarify what's going on here. So if I said for the DF object in the Y column equals 4, what I'm really doing is creating a little vector of true, false, false, and placing that inside my notation for subsetting the data frame, and saying, all right, for these rows, I want you to return, and I placed it before the comma, right? So I'm saying true, false, false, since there are 3 rows, basically return the first row. Okay. Sorry, I think we have like phantom TV turning off there. It's fine, it's back. Okay. So, oh, and then here's an important part that I skipped over a little bit. That $, that allows you to access variables in the data frame. When I say variables, I mean the column. The first row. So when we ran this, right, what it did is returned, here you can see the row number and the 2 column names, and then 1 and 4. So what I said was, give me the row where y is equal to 4. If I had said only give me, if I only wanted that value, what I would instead, if I only wanted to see the one value where y was equal to 4, in the column area of the data frame, I would have said y and told it that is the column I'm referring to, and it would just return 4. Okay, so, and I realize at this point we're talking a lot about kind of like building data structures and like building these vectors and building these matrices, and that can seem a little bizarre because I think often the way we approach like statistical environments is we assume we're going to pull in data and then kind of go from there, and the idea of building it is a little strange. But something that is really helpful in R is being able to sure import your data, but also like build structures that you can use in your functions that kind of like can work with the data that you're pulling in, especially if you're not more than likely going to use your data in like kind of the form it's already in. You're probably going to roll it up or have to like build it out a little bit. So that's kind of where this comes in handy. So if you did pull in a data frame from somewhere, or you just kind of generated one, something that's really helpful is being able to combine those data frames. And you can, at this point, decide whether you're combining like a data frame with 3 columns with a data frame with 2 columns, and you wanted them to all just kind of mesh together, right? So have it be a data frame of 5. And if that was the case, you'd use the cbind, which is column bind function. And with cbind, what R requires you to define in the arguments are what objects, the 2 objects that you want to combine. So here, df, which is the one that we just created, and then kind of impromptu within the function, I'm creating a new data frame. So data.frame, and then having it have one column called z with the numbers 1, 2, 3 in there. So you can kind of, like that is a function kind of nested within another one. And then row bind is similar. But as you would expect, if you tried to tell R to combine 2 columns, or to combine 2 data frames, each of which had a different number of rows, it might not be able to do that because it doesn't, if you gave it one column that had 5 values and one column that had 10, it wouldn't really know how to match those up, right? Ideally, they should be the exact same length or number of rows. And then same for combining by row. At that point, all the number of columns that you have should be equal. Okay, so I know we just like went through a lot of content really quickly. We're going to take a 10-minute break. If anyone wants to come by and like ask questions real quick, we can do that. But like we'll take a 10-minute break and kind of pick up where we're going, and yeah.
There should be a water fountain at the outside the doors.
Near the bathroom? I don't know.
That's a harder question.
Yeah.
So we'll be starting up shortly in a few seconds. So everybody could just get started. Please bear with us. Okay. So we are starting back up. Hopefully everybody had a chance to follow on before the break. So picking up where we left off, we're going to cover some of the logical operators in R. So what we mean by logical operators are just sort of the comparisons and the tests that we do, like you saw before, like the two equal signs. So very basic. When you see an exclamation point before a variable or a number or a data object, it is not that thing. So that's the test, not that. If we're trying to test an OR statement, element-wise, it is a single pipe, so a single straight line. X pipe Y is element-wise X or Y. The equivalent of that in AND is X ampersand Y. Now, what if we wanted to test just the object itself and not each element? So we want to test, say the thing is not a vector, but it's just a single element or a single data object. We do two pipes. So X pipe Y is object Y is X or Y. The equivalent of that for AND is X ampersand Y. So you saw probably before, two equal sign is the test for equality in R. So X equals Y is X exactly equals Y. That is a test. So you saw before we had these arrays, right, of multiple elements. So if we had one tested against the other, and we want to test each object individually, this is how we would do it. Versus the other one, this next slide, is to test the object itself against the other. Okay, so those are just our basic logical operators, tests that we use for our programming. If we wanted some of the special arithmetic operators, the basic ones are as you imagine they are: plus, minus, multiply, exponential. All those things are sort of carry over from all other statistical languages. The special ones are modulus, which is %%. So if you want to do x mod y, it is x %% y. And if you want integer division, it is x% /% y. If you just want the remainder. So knowing all this, we start with our basic loops that we do. So the syntax for a loop is basically for, in parentheses, your iteration across a data object, and then curly brackets, the commands you want to execute for each part of that loop. So here in my first loop is what I'm doing is basically for each element from 1 to 10, I'll call that element x, and then I will print basically x, that number squared is the square of that. So if we were to test this out, so I'll get to that. So paste is basically a way of combining different elements into a string. So x is obviously a number, it's 1 through 10, and then squared is a string. So what we're doing is pasting those together and printing them out. That's what I'm asking this loop to do. So let's test that out in RStudio. Where is RStudio? Okay. So for x in 1 to 10, curly brackets, oh, my bad. Print paste x squared is x squared. And so hopefully what we'll get is the output of that for each element from 1 to 10. So, oh, sorry. So the first line was just my mistake. I accidentally pressed enter too early. So I didn't put a command in the loop. So it looped through everything, but it didn't do anything. So then I can. So you can just press up and you'll get the command you just entered before in RStudio. Yeah, so arg saves a history of all your commands.
And in fact, if you see that history right near where the cursor is right now and you click on it, you can search through your history if you remember there was something you did that you thought was brilliant and you want to find it again.
Right. It's like, what happened?
Yeah.
I have all that hidden, so. Okay. So back. So that's basically our first loop of executing on everything from 1 to 10. Now, obviously, you may want to test conditional elements, like since we know all these logical tests that we're doing, let's do a very basic one, which is, let's say y is 5. If we want to test for any element argument, if it's greater than 0, we can do this test. And the test is basically if, parentheses, the logical test, curly brackets, the command you want to execute, if it is true.
So we have a question.
Okay.
What is the purpose of having the curly brackets?
So R defines all its functions. It parses all the commands in its script based on certain special characters. So the curly brackets tells it that for this loop or this conditional loop, that these are the commands that want to be executed within it. So anything contained within the curly brackets is what's executed. So it doesn't care about format or spacing. Excuse the noise, there's construction. It only cares about what is contained within the curly brackets. Mm-hmm. Right. So you'll notice in the slides I added spaces and additional lines, right? And in RStudio I just did it as one single line. And so that doesn't really matter so long as the actual command is contained within the curly brackets. So let's try the if loop or the if test. So let's say we want y this time to be 7. Now, if y is, let's test if it is greater than 0. Print greater than 0. And it does so. So let's change y this time to -1. And let's run the same test. and nothing happens because the test came up false. So I'll give a few moments for everybody to test this out on their own.
So why is if, I think they meant for, why is that a loop? Like, what is it looping through each time?
Okay, so for this one, I only have a single iteration, but if it's basically testing for each iteration of that element, that if that passes that test.
So it would run how many times here, do you think?
It runs only once, because y is only a single element. Okay, so obviously sometimes we want to extend that functionality to other conditional clauses. So let's say we had the previous function before testing if something is greater than 0. But what if we also want to know if it is exactly equal to 5? Then print something else out. Or if it's none of those things, print something else out entirely. So this function, the syntax would be if a conditional statement, then the curly brackets, your commands, then else if another conditional statement, curly brackets, the next command, and then if you just want nothing else, you want to end it to catch all the other conditional cases, just do else curly brackets. Huh? Yes. So at the first, you'll see in the first line, if y is greater than 0, it's saying print y is greater than 0. Now the next line it says, but if else, if it is equal to 5, print this is 5. Else, print none of the above. So it does catch up next one. So you notice my error in this, which is that it'll never hit the second clause because the first clause is always true if it is the second one. So it'll never hit the second one. So that's what you have to be careful about. So the order of these if loops is from top down. So from the first conditional statement down. So if the first one is always true and it captures the second one will never hit, even if it is true. It'll only print paste. It'll only print y is greater than 0. It'll never print this is 5, because 5 is always greater than 0. Okay. So paste is just the paste command is just basically asking it to print out what the variable actually is. So y is just 5 in this case, and the string. So it's asking it to print all of that out as a string. And then I'm passing that as a string to print, so it prints out. So it's converting that whole set of arguments into one string. Okay. So the next loop we're going to cover is while loops. So sometimes we want to keep going so long as the condition is fulfilled. And so in here, the while loop syntax is basically while that conditional statement do that object in curly brackets, that command. So here, what I'm asking is I'm first defining z as 1 to 10. And then I'm saying, so long as z is less than or equal to 5, print out z mod 4. So let's let's test that out. So let's assign z as 1 to 10. And now let's say while, print is a function? Yes. I'm sorry, say that again. Is everything a function?
No, like the z is less than equal to 5. That's the statement that we're kind of evaluating. But print is a function, while is a function. Assignments. Which? Oh.
Oh yeah. Yeah, it's not a function here. It's just assignment.
Yeah.
Yes. Here it is a vector. Yes. It is built in. Prints. Oh. So it does it every single time. Okay, that was my mistake. I wrote this too fast. Yep. Yep. Yes. Yep. Yep. So you just caught an error. So modulus is just, this is modular integers. So it's like you're in base, base 10 is what we traditionally use, 1 to 10. But base 4 is 1, 2, 3, 4. So we're only counting to 4, and then we're repeating. So it's like 11 in base 4 is actually 5. And so on and so on. Yeah, that number in that base, yes. Yeah, so that was the error, is that I'm iterating z and doing it every single time. No, it does not. Yes. So that was the error. So what should have happened is...
if you need help stopping that, there is on the top right of the console.
Yeah. So let's try that again. So if it loops forever, our studio will show up a stop sign on the top. You'll see in my mouse right here. You can just press it and it'll stop. Okay, so let's try that again. So if something like I just did accidentally happens and it runs forever, you can just press the stop sign and it'll stop. So what should have been is I should have looped through. Yep, so for, let's say, x in z.
For x in 1 to...
Oh, yeah, from x from 1 to z. 1. Yeah, my bad.
1 to, what is z?
Oh, yeah, it is a vector.
So number length.
Yeah.
Sure.
It'll loop forever?
No, right? Because it's going to... So
it's going to iterate, right?
Yeah.
Oh. Yes. Okay. Yes. Yes, there we go. Okay. My bad. Yes.
And since we know that it's got only 10 values in there, and if we know it's 1 to 10, you should only get 5 bits of output. It should only evaluate 2 5 times. 4, 5, and 6 and 10 are bigger than 5.
There we go. So we can also correct it this way. So what you need to do is iterate z while you're running it and add it.
So your initial
No, sorry. Yeah, so so instead of making z a vector, we initialize z as some number, and so for the while loop, we're testing z at that condition, and for each time we test it, we're adding 1, and then we're printing it. So it won't run infinitely because it'll catch itself at some point. So let's fix that in the slides.
And if you're having a hard time putting all of this in one line and you kind of want to be able to space it out like that, you should be able to do it in the console, but also in that window right above it where you have the script area. You can type all of this out and then hit run. If you have a Mac, you can just hit Command Enter. And that way you can also save all this at the end if that's helpful.
Yes, let me show it to you. So right here is the top window pane. And you can, this instead of the console is the script. So you can save a script here and run it afterwards. So while z less than or equal to 5, z plus 1, and then print z modulus 4. No, you can run it. Where does it run? Source on favor.
Command all. I think
source. Right?
No, it's that one next to it, or the one to the left. Sorry, you can tell that we don't know where the buttons are. So we just use the shortcut so much. But you want it to do the entire. You don't want it to run one line at a time. So I would honestly select it and then hit Command Enter or Shift Enter for Windows. And that way you can tell it which lines to run, because you're going to keep adding code to your script. You don't want all of it to run every time.
Okay. Okay. So next we'll cover is basic syntax for simple functions. And so the way we define a custom function in R is assigning it a name in the namespace. So basically here we're saying sum the remainders, that's the function name, and we're assigning it a function with the arrow, the left arrow, and saying function, the arguments we're passing it, and then curly brackets, returning whatever we want to return. So here, if we pass some remainders to numbers, we're performing integer division on the two numbers, and we're summing them. So actually, you don't actually need to sum them because it's just one number. Yep. Yeah, it returns the object in the parentheses. So let's try making our function, our own function. So let's call a function square, then add 5. It is just here. X, Y, and what we're going to do is exactly what the name function says. We're going to square, we're going to return x squared see, we're only going to use one argument, x squared plus 5. So square, then add 5 of 3. So hopefully that works. Yes. Bless you. No. It searches the namespace for the function name.
That work? Shift enter?
They're evaluated as strings every time. Yes, they are parsed. I'm sorry? What new variable did I create? Oh, okay. So the x in the function is basically not a new variable completely. It's just a variable that I'm calling in the function. So I didn't pass it in a new variable. I just passed it a number and telling it to run this function on that number.
Are functions temporary?
They exist in the workspace that you're current. The custom functions you define exist only in the workspace that you're currently in session. So if you save that workspace, that function will still be defined. But if you start a new one, that function is gone. Okay. So we're getting to sort of, after looping and after defining custom functions, a lot of the caveats to R are that it performs rather poorly on larger data sets. Not as bad as MATLAB or Mathematica, but it performs poorly compared to the conventional C, C++, or Python. So the question sort of oftentimes reduces to a question of performance versus readability. And what we're asking is, you can make the performance better, but often at times of making your script, your code, more readable. And so basically what R does is, when you define an object, it places it in the virtual memory of your computer. So it allocates that space. R is built to be extremely dynamic because almost everything can be replaced except for the default functions. So you can pass it basically anything, you can make new functions. And so because of that dynamic nature of it, it has to search the namespace each time you call a new function. And so there's cost involved in that. Yeah, so it becomes slower as you go on. So as you build a larger workspace. And so the question often is, are you going to do a vectorization, or are you going to loop through every element? So are you going to try to do individual operations on the entire vector, or you're going to try to loop through each element of that vector and do an operation. So it's easy to write very slow performing code in R. As you'll see, it's very easy to do an implement loop in R, apparently. If you input data, oftentimes you should only limit the input into what you want exactly, not the entire thing before, because it's going to allocate memory to the entire space instead of reading just the data you want. So that's a helpful tip. Also, oftentimes, you may want to do a vectorized calculation instead of looping through each element. So instead of the top loop you'll see here of looping through each element from 1 to the length of x and checking if it's greater than 4 and then printing the square of that element, you can do that operation on all of x at once. But what you'll see is that obviously the loop is more readable. You can go line by line and parse it, whereas the vector operation is just much harder to parse. It's a much shorter line. Yep. No. So it's in fact the opposite. So when you're loading in data, you want to limit the load, what you're reading from that data file to only the things you want. But when you'll see in a minute, when you're trying to run operations on a large object in R already, you want to define it to its maximum extent already, like before you start the loop. So let me get to that. So here, just going back a little bit, instead of looping to update each value in the data frame, we subset. And you'll see here before, we subset by x greater than 4, and then we square every element in that. And that gets you exactly the same thing you saw in the loop. I'm sorry, can you speak louder? Uh-huh. 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 Right. Mm-hmm. Like Krieging or the data set. Uh-huh. So what was the question from that?
I think you're saying, like, at what point is it, if you want to apply a function, any function, to all of the entire data frame, for example, what's the best way to do that? And I think that actually feeds in well. Like, it isn't to go through each element in the data frame and update each one. Like, if you were going to log transform the whole thing, you could just, like, if x is the data frame, you can actually just do log of x, and it'll update every value in the data frame. So, like, R is actually perfect for the example you described, the question you were asking, which for the folks on the phone is like, is it better to update each element individually or just update across an entire data structure?
Mm-hmm, mm-hmm. Yeah, okay. Right, okay. I get what you're saying now. So that actually carries to the first tip, which is that when we have large arrays or vectors, that we want to use just simple, when we have simple functions we want to perform on every element, that to do that function just on the vector itself and not on each element, not loop through each element. Right. Mm-hmm. Right. Uh-huh. Oh, okay. Yeah, so it's essentially map reduce. Yep. So the other tip that I often give is that you want to initialize in R the full size of the object. So if you know how big the thing is before you're going to go into a loop and loop on, so say you cannot avoid the loop and you have to loop through that every element in that loop, that object, instead of adding an additional element each loop or appending something to it or C-binding something to it, you want to create a giant, that object full size before you enter the loop. And so that allocates the entire memory instead of recreating that object every time. And then the last tip is just something very basic, which is do not, any kind of calculation you can pull out of the loop, you should try to and do it before the looping. So anything extraneous to that that you can do prior to the loop or afterwards, you should try to do that and not make that cost inside the loop because it iterates each time.
Folks on the phone are asking for an example of that second tip. What would that look like?
So say you have a matrix and you want to create a new one, but you're trying to square the elements. Instead of squaring each column and then appending it to a new data object, create that data object beforehand and add each element, update each element as you loop through it. So the difference there is one is you're basically recreating that object as you append each time, and the other is that you have that full memory already allocated and it's just rewriting certain parts of it. Okay. So next is how do we both subset and update an element, say in a data frame. So say in a data frame, we want to subset by a specific test or value, but we also want to update whatever that test is. So here in our data frame, we're saying for the column X, if it equals 1, return that column, but update that and change that value to 9. So what it does is it updates basically every value of 1 in the column where it equals 1 and changes it to 9. Yeah, it has to be named. That we're calling very specific. So let's try that in R. They are optional. You use semicolons if the question is, are semicolons optional? You use semicolons if you're passing one command in a single line and you want multiple commands.
But don't.
But don't. If you're writing a script, yeah. So the general tip is if you're writing a script, try to parse it out so people can read it better. Okay. So, wait, spoilers. So what we're trying to do here is, let's try this. Did I define? So let me define df again as a data frame. Data.frame x equals 1, 2, 3, and c 4, 5, 6. And then df will call x equal to 1, and we want x, and we want to update it to 9. So hopefully that works. And let's see what df is. So you'll see the 1, the first entry changed from 1 to 9. And so if we go through just what happened in that line, basically we're testing a true and false logical test on if for each row the x elements of that row is 1. Now we're saying in the second argument, give us only that column, give us x only. And then with the left arrow, we're assigning it at that new value. So we're locating exactly where in memory that value is stored in, and we're updating it. Okay, and we'll have a 10-minute break, and be back shortly. Yep, I'll put my last slide up.
So 243.
Okay, so we'll be back in 243. Yep. So for the people on WebEx, we'll be back at 243. Feel free to contact us through the chat. I'm sorry? Yeah, basically.
Except for here, like you're actually rewriting it. You're not just like saying max that 1 to 9. You're changing that 1 to 9
In the actual
in the
object.
actual like data frame.
So we're updating it.
Yeah, you're. Yeah.
So we'll be starting in a few minutes. Or a few seconds. Just press up.
Well,
Or in the history in RStudio. Yeah.
it'll
Yeah.
go for a while.
Well, it
Okay,
saves.
your entire session.
Yeah, it saves the entire history. Because when you quit RStudio, it'll ask if you want to save it. Okay. So let's get started. The next section we're going to cover is importing data. And so we're just going to cover a few typical cases I think most of people who work in the government will encounter. If a file's in a table format, you can the command is just read.table the file name. I've actually never encountered that. So in all honesty, I don't think I've ever used that command.
Once with from other R maybe, from other R code. It's rows in columns.
Yeah.
So, this works well for like dot dat.
Oh yeah, so like a traditional like a tabular separated, like a tab separated file or something. The most common I've probably ever seen is a CSV, which I think everybody here has encountered. Or if you work with Excel, you can save your Excel worksheets as CSVs, comma separated variable files. And so the command to load that in is read.csv, the file name in quotation marks, the separator in the CSV, which in this case is a comma, and if we want to keep the header, if the header is there or not. So header is true. So the question is, how does it handle quoting? I believe.
Like inside the values of your CSV. So if your CSV has quotes in it, that's fine. It's only going to separate it based on the commas.
Yeah, I think it just passes it as a string. Yeah, you can change the separator. That's the only way I think you can. The other format that typically I encounter is a fixed width format, so you know for a certain number of characters what this value is. Here, what you're passing is again the file, but then you're passing a vector of the widths sequentially. So say the first variable you know is fixed width of 4, and then 3, and so on and so on. So you're passing that, then you're telling it if there is a header or not, and then you're passing if there is a separator or not. Yep. Okay, question? Mm-hmm. 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 So the comma is as so the question is, there's another comma right after in the read.csv after the separator. There's another comma after separator, and what is that? That's telling an R that I'm passing an additional argument for read.csv, which is header equals true. That there is a header in the file. Okay, so I think probably something very unique to the government is that a lot of people counter SAS 7 BDAT files. If you're working in SAS, I think like Census or maybe BEA, they mostly work with SAS files. And so built into R, there's no functionality to parse those files and load them into R. But there is a package, being that there are like more than 6,000 packages in R, that allows you to read in SAS files, SAS data files. And so the command to do that is hopefully everybody's installed that package, and you can try it out with your own data set when you get back, is library SAS 7 BDAT. And the command looks just like every other one. It is read.sas 7 BDAT, the file again, and then debug equals false. So if you ever get confused about how these commands work, what they do, the double question marks in front of the command will just look for help in R. So if we go into RStudio and say read.csv, let's see what it gives us. It'll pop up the help on the other side in RStudio, and it'll search for that function. So here you'll see the function and what you need to put in, what are the arguments that it'll take, and all the documentation. And that works for any command in R that it's defined. Mm-hmm. Mm-hmm. How large is large? It's really virtual memory limited, so it's RAM limited, depending on what you're running on. So if you're on a large server and you have an instance of R running, you may be better off. If you're on a local computer, you like maybe 8 to 8 gigs for most computers right now, most laptops. So you're mostly limited by that amount. So what's the data set you can do?
Actually kind of depends also on like how you pull it in. So if that data used to be a CSV, so you're going to build a data frame, and I mentioned those are kind of expensive, you would have less leeway with that than you would with like a big matrix of 1, 0. No, not a billion.
No, it's on the order. It's on the order of million. Is mostly for a personal computer, is where you're stretching it. Okay, and you'll notice if we go back to the help, it lists all the read functions, and you notice most of them have a separator argument here. And what that separator argument is that it runs that specific separator for that function for default. So we can pass a new one in, but for read.csv, the default separator it looks for is the comma.
There's a question as to whether is read CSV a package they have to install?
No. So read.csv is not a package you have to install. It comes with R by default. So, but what if you also want to pass specific names to the columns that you're importing? You can pass column names. And so you'll see the syntax here is how you would do it. And if we go to the help, so it's part of the extra arguments you can pass to it. So it's a column name. So if you know specifically what the names of the columns you want them to be called, you can pass call.names and a vector of the actual names. Okay. So let's take a closer look at an argument with more for reading CSV. So if we're reading a CSV in, the first argument obviously is the file name, the file path, and name of the CSV. The separator here you'll see is the comma that we defined. The next thing we're saying is whether that file actually has a header, has a top row that has column names in it, has a header in it. The next argument is na.strings, which is saying, what if we get strings in there? What do we treat it as? Like, what strings do we get passed to treat as a not a number? And we're missing. And so we're passing NA, null, blank, or a space, and it'll read through the CSV as it loads it. And anything that is one of those arguments, it'll replace it in R as an NA. That's missing. And the next one, we're saying blank.lines.skip, which is pretty self-explanatory, which is saying, do we want to skip lines that are blank? True. And so there are ways to load like specific Excel file formats to R, but our recommendation is just save it as a CSV, which is much faster. Right. So say you have like this is accounting for certain things. Say like data sets that say like like by default if nobody it doesn't know the name of a customer, you're putting in customer names for each one. It just defaults to like John Smith. You can put in John Smith as an na.string, and it'll replace it with a missing because you know specifically that is a missing value. And again, if it's dirty in the way that like there is blank lines in the worksheet, you can say, let's skip those. And so this is just sort of arguments you pass to it as you're loading the initial data in to sort of give a first pass of cleaning it.
So a question is, how does doing this, say, for example, defining blank or what the NA strings are, how does that impact how you're going to treat that data set? Like, why are you doing it?
Okay, so if we don't specifically define what values are missing, they will be imported specifically as strings. So even though it says NA, if we don't specifically specify it, it'll be pulled in as a string NA or a string null and not an actual missing value in R. So R will not treat it as a missing value, it'll treat it as a string. So R has a lot of functionality for dealing with missing values. Say if you want to impute new values into those missing, you can search for NA by those. You can subset by NA. You can omit any column or row that contains missing values, and that's only possible if you defined it as missing. It depends on what the function is. That's extended. Okay, so looking on. Say we've imported a data file into R, and we just want to take a look at it. Say it's a very large Excel file or a CSV file, and we want to look at just what it is. Here are some arguments that get you sort of what it is. So the head of a file gets you, as you'll think, the first few rows of the file. A tail of a file or a data set, or is just the last few rows of it, just the top, the beginning or the end. And a view, capital V view, so caps matters of the file gives you a spreadsheet, traditional spreadsheet style of that file. So we'll go through that in a little bit with an example data set that everybody should have. So yeah. So R comes with default data sets. Like most statistical packages will come with certain famous data sets that you can test out as you're learning. So if you want to see the list of data sets that R comes with, you can type in the first command, library help equals data sets, and it'll show you what data sets are already installed on your computer that you can mess with. So let's try that out. And here you'll see the documentation for data sets. And these are all the data sets that R comes default with that you can test with. And these are all rather famous data sets you'll see. I think most people probably have encountered Iris, which is the Iris flowers data. But these are just things that are already there. You don't need to download if you ever just want to run some functions on or test something out on. What we're going to use today for our exercise is a data set that comes with ggplot2. Hopefully everybody's installed that package. If you haven't, this data set you won't have it, and you can try it out later as you install it. But for everybody to call up diamonds, that's the data set we're going to work with. You should have to initially load ggplot2. So the command for that is library ggplot2. So let's try that. Okay, and so once we've loaded that package up into R, diamonds will be available for us to call. So let's look at what diamonds is offering us just ahead of it. So you see, it's a data set that contains the following columns: caret, cut, color, clarity, depth, table, price, X, Y, and Z, which I'm assuming are the coordinates and the depth that they found the diamonds in the mine. ggplot2. So that is a package that contains the diamond data set that we're going to work with for our exercises. So, yeah, so I believe it might be like the actual three-dimensional coordinates in the mine that the X, Y, Z is that where the diamond was found. Oh, it might be that too. Yeah, so it might be the actual size of the diamond. So some ambiguity, but so basically this is what the diamond's data set is contains, and let's see if we can look at something more. So we can convert it and just look at what is structure? Yes. Okay. I always want to say string, but str is the structure, and what is the structure of diamonds? So we'll see that the caret is a number, cut is 5 levels, and so on and so on. You can see for each variable, each column name. Okay, so as an exercise, everybody can just take a few minutes. If you have diamonds loaded up, take a look and just run some of these commands on that data set and see what you get. What are the variables? What are the data types? What's the size of the data? You would put diamonds, the actual object that you're calling. So it's just maybe a minute or two for everybody to test this out, and we'll go over it ourselves. Uh-huh. I've never seen that. Our session aborted? Huh. But that's supposed to call up your default installer. So is RStudio calling the user local one?
No.
No, it doesn't.
RStudio
You
requires
need
R.
R installed for RStudio to work. Yes. We double checked that prior.
If you go to RStudio download, it'll tell you to download R first.
Mm-hmm. So have you installed ggplot2 prior to this? Okay, so probably they didn't. So they probably only installed R in RStudio, and so ggplot2 is an additional thing you have to install. Are you connected to the Wi-Fi? Where, you can just type in install.package, parentheses, quotation marks, ggplot2, and see if you can install it. That I'm not so sure. Okay, so let's take a minute and see what we get for each of these commands. So let's try names of diamonds. And we get the names of the columns. Let's try dimension of the columns, and you'll probably guess what it means. It gives you the dimension there, where if this goes away, of the column. So it actually has 53,940 rows and only 10 columns. And so let's try that. Obviously, n row and n column just give us each of those, the number of rows and the number of columns. We just tested structure, which is str. Let's try summary of diamonds, which is particularly useful if you're just looking at a base data set. And what it gives us is just basic summary statistics for each column across the board. So you'll see for carat, because it's a number, it decided to give us the minimum, the first quartile, the median, the mean, the third quartile, and the max of that column. And it does it when you do across every column. So summary is a very easy way of getting just basic exploratory sort of data statistics that you're looking for. So you see a cut is ordinal, so it's 5 levels. So it gives us just the count of each level. So it automatically adjusts for each column in the data frame. Here again for clarity, and so on and so on. So let's try view. So view has to be capital. And it gives us, as you'll see here, a separate window in RStudio that looks very traditional. You'll probably count if you ever worked with Excel. Just a very spreadsheet view of that data frame. So this is what view gives us. Again, sortable. Okay, and so with these commands, it's very easy to look at, like, well, how many rows do we have? How many columns do we have? What are the names of the variables we're working with? Because we loaded this data set in, what is the data type of those variables? Like, what are we encountering? Sort of the basic summary statistics of those to get an idea of what we're dealing with. So next thing we're going to show is how to sort and reshape that data that we've just loaded in. So what if we want to resort the actual data frame we're talking about and order it by a certain variable? So here in the first line, what we're telling R is for the data set diamonds, the data frame, we're going to reorder it. We're going to reassign it a new value, which is diamonds again, but reordered as for carat. So let's try that specific argument. diamonds, and we're going to reassign it as diamonds, but ordered of diamonds caret. Hopefully that should work. And let's check the head of diamonds. Yep, by caret. And you'll see by ascending order, yes. Yes. And we passed it in the row argument of the order. Yep. So basically, just to go through the command, what we're telling it in this line is that we're saying for the data frame diamonds, we're going to reassign it a new variable, new value, which is diamonds again, but only this time ordered by row, because it's the first argument in the square brackets, reordered by the caret. So we could do it in the spreadsheet, but what? Yes. Yeah, but the spreadsheet view only is a temporary view of it. It doesn't. What we just did in the in the console is we actually reordered the actual object because we recreated it with a new, basically recreated it. No. No. So R is dynamic. So the question is, it's pretty easy to accidentally, mess up your tables, and that is true. R does not check for those things. It only checks for very basic syntax errors. So if you pass it something that it can interpret, it's going to do it. There's no sort of quality assurance component of it. Yes. So yes. So another comment was that the basic statistics can help with understanding what table you're working with and avoiding mistakes with that table. So that's why typically we went through the exercise of looking at the structure of the data set, the names of the data set, the dimensions of the data set, before we do anything with the data set itself. Okay. So let's try and reorder it this time, but descending order. And it's very easy. The command is actually just the negative of that. So let's try that. Oh, God. Oh, God. Okay, let me go back. I just slided through everything. Okay. So you'll notice it's virtually identical to the first line, the sort by descending. It's just we put a minus in front of that order. So let's try and order it by negative. And let's see what it gives us. And you'll see for caret, it's the exact opposite, right? We reordered it, descending this time. We can also do multiple conditional sorts. So say we want to sort by both caret and the depth, we can do that. And that's only passing multiple arguments to order. So say we have a diamond, two diamonds of the same caret but different depths. We want to order that this way. I think it depends on what so for the cut, if it's ordinal, it should have an implied structure order to it. So when we looked at, so let's go back. So the question was, it has to be a number for it to order, and that's not true. So if we look at diamonds, the structure of diamonds, you'll see that the cut is an ordinal factor, so it has an implied order to those levels, and you'll see here it's going from fair to good to so on and so on. So if we order it by that, it should order it that way too. So we can try that. Oh, because it's negative. That's not meaningful. There we go. Yes. So if we accidentally put the wrong array in, you can mess up your data frame. And then here that argument I just passed, which is the order by diamonds cut, we ordered everything by that level because it was loaded in an ordinal value. So there's an applied structure of what the levels go ascend in, so that way we can sort by it. It's just like names, like John Smith, or just like pure strings. There's no implied order to them, so that may be you cannot sort by those. Yes. Yes. So this is only changing the data frame in R, in the actual memory that's loaded here. It doesn't change, say you loaded this from a CSV or from something else, it doesn't change that at all.
Someone is asking if there's any rollback commands to undo the last thing that you did to an object.
Not that I'm aware of. I don't believe so. So typically, if you mess up data frame in R, that's only messing up the object in memory. So if you're loading that data set, which I believe most people who are using R will be loading in additional data sets, if you're calling that original doesn't get changed. It's only the one in memory that gets changed. So you can always just wipe it and start over. Can you undo the kernel? Right,
Yeah,
which is which is essentially the same thing. Right, but there's no undo a command in the kernel. So there's no undo, there's no specific undo in R itself. You'd have to redo everything you've done so far. So it sounds tedious, but the advantage is that you're hopefully writing a script and not putting things into the console line by line. So as you're writing the script continues on. You can save it, and so the cost of rerunning it with a minor correction is not that much.
And I mean, something I do that's not really cheating, but like you can just, if you name a data structure A, just create a second one called B, right? Use your assignment operator, make A equal to B, and then work on B. And then you always can just pull from A again. Right. Totally mess something up.
So we don't necessarily have to update diamonds, right? We can change it and say, call this anything else we want. So say diamonds backup, right? And what we're doing is we're taking the original diamonds and we're assigning it to the new one. And so if you're afraid that what you're doing is going to mess up your original data set, you can just create a copy and try it there and then update it if it's correct or not. So here, we've just assigned this order to diamonds backup. And if we look at diamonds backup, it now exists. Okay. So something you can work on and try on your own is try sorting by the caret, ascending and descending, or by any of the numerical values. See if you can do it. Any of the column names on your own and see if they work out. So I'll give everybody a few minutes just to try to test that out on their own. And then we can practice that afterwards. There's a sign up there with the Wi-Fi. So I'll go back to the last page just for people to check. the syntax. But remember, any function, if you're confused about how to pass arguments to it, just do question mark, the function name, and R will search the help for it. Yeah, because that's the function you're confused about, if that is the one. Yeah, question? Because it is a row column, right? It is a two-dimensional matrix. And so what we're telling it is that we're ordering the rows by this reorder of the rows. That's why we need an additional comma at the end. Okay, let's try some of these out. So just so everybody's on the same page, let's look at all the names of the columns in diamond. So we have caret, cut, color, clarity, depth, table, price, X, Y, and Z. So let's just pick a random one like price and say we want to order it. So like, let's not reassign a new value. Let's just look at the head of that reorder and say diamonds, square bracket, order, parentheses, diamonds, and we want the price. That's what we're trying to reorder by. And comma, and hopefully that should work. So diamonds, the question was we never loaded diamonds in. So diamond comes with ggplot2. So the minute you call ggplot2, diamonds is loaded in. It's one of the data sets that comes with ggplot2 for you to test ggplot2 with, which we'll cover later on. Like we said, R comes with a lot of default data sets to test a lot of its functionality. ggplot2 and some other packages you'll find also include data sets for you to test them out. I believe so, yes. So the question was, if you have a diamond data frame or object already defined, when you load ggplot2, will it be overwritten? And it will, because it reserves that namespace from that library. Yes. Yes. So when you quit out of R, there's multiple ways you can write the CSV to a new CSV if you want. You can save the workspace. So when you quit out of RStudio, it'll prompt you to ask you to save out of the workspace. And that what it actually does is it dumps all the history, all the commands, all the memory into a file. And so when you open it back up again, it'll load that back into memory. So you can continue where you left off. So you're not losing anything when it shuts down.
The only thing apparently does not load when you load that saved kind of workspace is the library. So if you ran the library code function for ggplot2, it won't load that again next time you start up. It'll prompt you to do it when you try running a ggplot2 function.
But ideally, you should be not inputting single line commands into the console. You should be defining these into a script and saving them. That way, every time you run it, it restarts all over again. So all the commands you've worked on have been saved. You just press the floppy disk, save current document. So where my mouse is, and it'll save the file. Okay. So what if we want to do higher order sort of linear algebra functions? What if we want to transpose that matrix? So for people who aren't familiar with transpose, it's basically saying we want all the columns to become rows and we want all the rows to become columns. How would we do that? And that function is actually very built into R. It's just T, short for transpose, of that object. Yeah, so if it's a two-dimensional matrix, so if it has rows and columns, if you want to reverse them and make the columns rows and rows columns, this is the command, T of that object. Okay. Now what if we want to blank a column? We want to remove it from the table. We say we don't need it anymore. We've done the function on it, or we've gotten the information we want from it. We don't want it in memory anymore. What we do is we call that specific column and we null it. So null is a special value in R, all caps. It's one of the special values like true or false. They tend to be in R, all caps. So null, it just means blank it. It deletes it. So say we wanted to do this on Diamond's backup. The price, and we wanted to null it. See, I did lowercase and it suggested that is, you probably want uppercase. And here, if we look at the names again of Diamond's backup, price is gone. We've removed it from the data frame. So what if we want to do sort of basic summary counts and put it into a new data frame? The last line is how we do that. So if we want to put in the count of diamonds by the cut into a new data frame, this is how we would do it. So let's test that out. As.dataFrame. Because we're telling it, we're passing an object and we're saying convert it into a data frame of a table of, what is it we're using? The cut. So the diamond cut. So table of diamonds cut is basically saying give us a table by the cut of the diamonds, the counts, the counts, the frequency of the diamonds by their cut, and then convert that as a data frame, and then assign it to the variable cut, the object cut. And so if we look at head of cut, this is what we get. And so for people who remember, if we look at the structure of diamonds, cut is an ordinal value, right? It has several levels. And so what we just did is we did a count by those levels. Okay. So let's try transpose too. So just T of diamonds, or let's try diamonds backup. let's give you the head of it. If you go back, that's just us saying for any column name, that column is called table. It's just an example, it's a placeholder. So it could be anything there in the second line. I'm sorry, where?
Oh.
Yeah, and that's saying a column name called table. Yes, yep. But so like if it's table followed by parentheses, it is specifically a function. But you can still use it as a column name, as a string.
If you just typed in cut into your console, it wouldn't know what you were talking about either. Like you kind of have to tell it if it is a column that what data frame you're looking at, and then if it's just table with open parentheses, it's a function. Yeah, exactly.
Yes.
There you go.
So you'll see R is dynamic, and it allows for multiple naming, multiple different things to be named the same thing. So cut is actually a function. So if we do cut, let's see, why is it auto suggesting? There we go. You can actually see there's numerous values of cut, but we also assigned it a data frame object called cut. So R allows for that dynamic nature. So just again, to reiterate, like what that last line was doing is we're saying assigning cut create a new data frame from this table of diamonds of the counts of the diamonds cut. Okay. So I'm going to pass it off to Pri for basic analysis.
Okay.
Let me share.
Okay, so the first place we'll kind of start with are just the basic summary statistics you might want on the data, on the columns of the data frame you have. So for the diamonds data set, the data frame that you have up, mean is a function that finds the mean, it finds the average. So if you pass in, if you pass the argument of diamonds price into mean, it'll find the mean for you. Same for standard deviation. Summary, which we saw earlier, is more, will give you more like metadata type information. Oh, sorry, I haven't actually loaded in. And so that'll give you things like if it is a numeric value, it'll give you the first quartile, third quartile, the maximum value, and all those things that are actually pretty helpful when you're dealing with numbers. But something that you might want to be able to do is that hopefully everyone created that cut data frame, which was a data frame that had one row for each value of cut and then the count of them. And so if you didn't do that, you can just type in that command right now. Sure.
So the question was, what would the expression look like if you wanted to access more than one variable in the data frame?
So if you wanted to, let's say, pull out both color and clarity, you wanted to just see like a color and clarity. So exact same kind of structures before with the square brackets, but under where you put in, where you'd usually just put in, let's say, color, you would pass in both using that C function. So color and then clarity. There we go. And it shows you both.
Added that.
So something you might want to do is have the mean price by cut. So you already have the kind of count of, let's say, diamonds here by cut, but you might also want like the mean price for each of those cut types. So what this function is doing, tapply, is you're saying, okay, take diamond's price, which is the thing that you're creating the mean from, the index, which is kind of the grouping that it's doing the mean on, is the cut, which again is from diamond's cut, and then the function is mean. So as you can see here, even though we are adding a new column to the cut data frame, right, because the cut data frame only had 2 columns in it. So by using that dollar symbol operator and then creating a column name that didn't exist before, it's actually just going to impromptu create it right there. And then using tapply, it's pulling all of the diamond price values, grouping it by the diamond cut, and then creating a mean of those values and putting it in your cut data set. So a couple of different things are going on there. But you can see how you can pull like summary statistics from your big, large data frame and create a smaller one that has these aggregated values. I'm sorry? Oh.
So does the argument index have to be capitalized?
So it does not have to be capitalized. In fact, so you actually don't have to have the argument label in there at all. If you start typing it, it'll autocorrect it to that fully capitalized version. But you'll actually notice there are a lot of functions, and you might have seen this before, where we didn't say what it was that we were passing as an argument. We just put it in the right order. And while that's totally fine, if you want to have more readable code, you could actually include the labels as well. Otherwise, you're counting on knowing the order of what it's expecting. Diamonds is a data frame because it has, oh, did you ask about the whole data frame? Oh, so data frames are a list of vectors. So when you're asking type of, it's actually evaluating that like kind of most high level structure, but within those lists, within that list, there's vectors or things like that in there. Where does it store the name? Within the data frame? It's the column name. So call names or names. So similarly, just like we have the tapply function, we can actually run models in R, which is the best part. Here's a linear regression model, and this is an example of an instance where there is specific syntax that it's expecting for the arguments in the order within the parentheses. So here we're saying the predictor is caret for diamonds, and kind of the target is price. So like if we're building a model to see if there's a linear regression kind of linear relationship between the two of them. And you could do a summary of that. So let's okay. You can see here we ran a summary on the model that was built, and it says, okay, the formula was price and carets. Here are residuals. Here are coefficients for carets, and like whether or not they were significant. Linear model, I think. Yeah. Yes. In fact, that's good segue. Plots.
The question was, can we generate diagnostic plots for that model?
Mm-hmm. So kind of taking a step back, like, and this is why this is kind of under this basic analysis section, right? Visualization is actually a really important way to get to know your data, and R makes it really easy. So there are base plots in R, and when I say base, it means that like, you wouldn't have to have installed any packages. R comes with the function plot, for example, and that works fairly well. They don't look great, but they're very, very quick to get up and running. But we're going to use ggplot2 by Hadley Wickham. So we installed ggplot2. Everyone should, actually we already did the library ggplot2, which is how we got their diamonds data sets. And so I'd like to pause a little bit and think about like what are questions that we can ask about this diamonds data set, right? So we all kind of know what data is in there right now. But since we have caret, cut, color, clarity, depth, like what are some basic questions you imagine someone might have about what's in this data? Just having only done like some summary statistics. And again, whatever we've learned so far. You can take some stuff from the linear model. I imagine it's something to do with diamonds. What is X, Y, and Z in diamonds? I feel like let's pretend that it is the center of the diamond. That's what I've decided. But like I imagine something like really superficial, like that we don't need subject matter expertise. Is like, okay, if there's a price, does that vary depending on the color or the caret or the cut? Do I have any like bits? Like, do I have a whole bunch of really expensive diamonds in here? Is clarity something that's really rare for some of those values? Like things like that. Yeah, and we only got it. Yeah, and we only got that little bit with that summary function, but actually we're going to take a closer look at that right now. So let's say if we just decided we're going to look at the distribution of cuts, which is what you were saying second. First, let's look at are caret and price related at all, right? So we know caret and price are two continuous variables. They're not categorical, so scatter plots are pretty great for that. So try running this. Qplot, and then you're telling it what your X and Y are, caret and price, and the data, diamonds. So center of the diamond?
No, it's the width, length, and depth.
Oh, okay. Cool.
So I'm getting comments from WebEx. If you do question mark diamonds, it will describe the variables.
Oh, cool.
In R.
Mm-hmm. So there actually R is kind of built. Did it work? Oh, in millimeters. Someone is trying Qplot, right? Okay, cool. And if let me do it real quick. Okay, so this plot is loading. There you go. So it's pretty not great looking. But you can see what the general relationship is, where as caret increases, price kind of increases too. One thing you might want to do right off the bat is like when you have data that does look a little skewed,
log transforming it will help, and that's something you can do within the command itself. So as you're passing caret or as you're passing price, you can log transform it, and you're not actually updating the old data frame. Like, you're not updating the diamonds data set. You're just, before you pass in the values here, you're just log transforming. So it's temporary. Yeah. I think it might have accepted it, but ggplot2 is kind of, they made it so that there is a separate function for data, and I always prefer using that because it makes it so you don't have to, one, repeat the data frame name multiple times. So, one, you're not going to make mistakes, but also it's easier to read. And something you can do if you do want to just refer to column names and not pass in the data argument because a specific function doesn't let you, is you can actually attach a data set. It gets a little bit tricky though, because if you attach a data set and the function is attached, if you have a column name cut, it's not going to accept that. It'll either overwrite cut or overwrite the function. So it's a little bit tricky to do that. But. So there's our log transformed value, or a plot. And then this last one is just another example of being able to do some work on the data as you're passing it in. So here, I'm dividing price by caret, so that it's a scatter plot of caret on the x-axis and price divided by caret on the y. So making it colorful might help a little bit, but you can map variables from your data set to size or color using aesthetics in ggplot. So here we have our plot of caret and price in data as diamonds again, but now we're telling it to color each of those circles based on the color column, because there was actually a column named color. When I first saw that, I thought that was so let's try this. Color.
Well, no, ggplot2 is Hadley
Hadley
Wickham,
Wickham,
which is British, I believe.
No, I think he's from New Zealand
Is he?
too. Yeah.
Okay.
Or Australia, one of the two.
It's one of them.
But he lives in Austin now. Not that I watched him very
Yeah,
closely.
so that's why it's colored with a U. The spelling. It takes a.
It'll take ordinal factors. It'll take a continuous variable as well. It'll just assign like it to a scale of color.
Yeah, it has its own internal scale of too.
So there you go. And you could see how, like, if you wanted to do the same thing where caret each circle was related to the size of the caret, that might be helpful. You can also set the shape to cut. It looks pretty ugly though. We can give it a try. I don't generally find shape to be a good thing to edit. It's pretty hard to, anytime you have more data. So something else you might want to do is have different plots, have that same plot run multiple times for different subsets of your data, right? So this terminology is a little bit weird, but faceting with ggplot2 has to do with picking like how you're gonna subset your data. So it asks for row and column variables. It's not asking for the row and columns of your data frame. It's saying, okay, if you want to see this broken out by the color of the diamond? Do you want it to be in a row together, in which case you're passing row as color, or do you want it to be in a column, like one after the other? So it's the rows and columns of the big set of plots. So we can look at that.
So we have a question before you move on. How do you get the plot to come out in its own window instead of just in the console?
Oh, on the bottom right, above where the plots tab is, or below it, you can see the zoom button. And I'm kind of zoomed in right now. But there are a few other options. You can export it as an image, as a PDF. You can also just copy it to your clipboard. Yes, you can sample like bits of the data. Yeah, I think it's just random actually. Sample. Oh. There you go, random number generator, which can be helpful if you're pulling a vector, or even data frame, I guess. Takes a sample of the specified size. So if we want to see different plot for every, for the price and carat for each diamond color, what we can do is qplot, carat, price, he does diamonds again. Oh, thank you. Facets. There you go. Ooh, make that a little bit bigger. And when you resize in the zoom, it kind of recalculates it, which can be a little bit funny. Yeah, so there you go. So this dot right here, so the syntax for when you're passing in that facets argument to qplot is it expects what you want broken out for rows, like one after the other, before the tilde?
Yes.
Okay. And then after that is column. So we said color, which is why it broke out those 4 or 5 plots next to each other. But here we can do both color and clarity. It really depends on the function. So in this one, he's just using it as a separator between how you're breaking out the row and the column. But for linear models, you're also passing in actually different variable names from your data set where you have the target on one side and then the predictors on the other side of the tilde.
So the question was, we've seen the tilde sign, the character multiple times. What does it stand for?
So, and that also means it's not like the standard operators. You should always look at the documentation for the actual function.
So it is
for
contextual.
That. It's contextual.
I'm sorry? Oh. I'm unaware of what it does basic. It usually, you either use it in an regression or in a plot. So it's usually describing some relation between the two, and it's differentiating between them.
I want the low price, $5,000. I want the lowest data point.
So the question was if we wanted the simple plot, but with all the prices less than 5,000 a different color. Is that possible?
Sure. So sure. So here's the first thing I'm going to do. I'm going to decide that I'm going to create a price separator, right? Where what I want to do is say for all values of diamonds, where diamonds dot price is less than what, well, let's see actually what the distribution, what's the summary of diamonds, because I don't know if that's actually a valid value. So if we look at the summary, it'll give me first, median, max, right? So I'm going to say price less than our median of 2401.
What price, right?
Hmm?
Oh, no, yeah. Never mind.
Actually, I'm going to make a backup real quick. There we go. So I'm going to update all the instances where price is less than 2401 and say that that is and all instances where it's greater than or equal to 2401 that's false. Right. Actual price. So what I can do now is I have a new column that has broken this out into two kind of categories for me. Either it's less than our median or more than our median. So what are we trying to do? Qplot caret price and then color by that. So qplot caret price, data is diamonds. And I would like it to color by, what did I call it? Oh,
Color with
price.
the U.
Color with a U by price. Did I not create it?
Capital P.
Oh, thank you. Ah, I see what you're saying. Mm-hmm. Yeah, and you can actually, I believe, get that gradient this way as well. Sure, yeah, I mean, it really depends on what it is that you're trying to do with your data, right? So if you wanted to do what you're doing before, which is kind of delineate all the ones that are below the median, there's that. Or if you want to give it a gradient, you can do that as well. Oh, yes. And that's actually just size. And so you can assign size a variable like caret, or you can actually just assign it an absolute value if you don't like the size of those circles, which I don't, just to make it smaller. Yeah. So this was the part I was talking about. When we're passing in facet arguments to qplot, it means columns that way and rows that way. So let's say we wanted to go back to talking about like the distribution of cuts. Okay, we have only 1 minute left. So I'm going to skip the distribution component which is basically how do you do like a histogram or a bar chart, and also like how do you change the bin width. So you should absolutely feel free to just copy this code. Okay. And the last thing I'll cover is, as you saw here, and actually I think the folks on the phone saw me, or on the WebEx saw me do this as well, there is a huge wealth of resources for R, which means that there are not only people out there that are really good at it and they post about it, but if you're running into a problem, more than likely someone has had that exact same problem that they've posted about. So in addition to using the native like question mark thing in the command line to look up functions, you should just Google it. You'll get a lot of hits. Stack Overflow is a really good place to get to find like the problem with the error you're getting, or to figure out how to do something. And also the last part, I'll talk about this, and we actually included a link at the end, is if you are putting a problem out there, if there's something that isn't working with your data or with code you're running, while you may not be able to actually put the data set out there, you should always put like really reproducible problems. So Stack Overflow is great. If you ask a question, you should make sure that you're not just kind of asking an abstract. Include a bit of your code, like show them what's going on so that they can recreate it and help you troubleshoot it. It's a pretty great community. So the last part is like we have a lot of really good resources. Hadley Wickham, I'm a big fan, so he's been mentioned a couple times. But also there's Google's R style guide, which talks more about like how to make your code readable and also look like it was done by someone that is comfortable in R, because you're using all kind of the right syntax for other people to be able to understand your code quickly. And Swirl Stats, that's my last plug. It'll let you learn R in R, so it's on the command line. So it like prompts you each time, and you're typing along while you learn. Yeah, so that's it. R is open source.
It's open source.
You mean within the Department of Commerce, or? So the two original developers, both their names starts with R.
Yeah, that's why it's called R, because both their names actually start with R.
So Rob and Ron or something.
Yeah, but like I think Ross something.
Yeah, Ross is one of them.
He's on a board. There's a board of people on the open source. There is no office. It is not a private. It's open source.
It's open source. Anyone can contribute to it. Nope. No, it's all community.
It's all community driven.
Oh, like include it as some code separately?
But that's all part of the presentation too. So there's the landline. Oh, okay.
Oh, I see. Like just grab my history today. All right, cool.
Okay,
I'll do
we
that.
can upload that to the GitHub.
Yes.
Okay.
Yeah.
Huh? Yeah, we're gonna send the PDF and the recording of this session and post it on GitHub. Thank you, and thanks to everybody on WebEx.
It was fun listening into this. Because you were like.